Differential geometry is as vast and as deep as an ocean. Now, how can we learn the fundamental concepts out of that easily? How can we grab the most important fundamental concepts which are the basic foundation of this subject? What are the best online resources available? Shall we have to start right from point zero and read everything through a book, or there is an effective time-saving path? Well, in this video, I'm going to talk about how to learn the fundamental concepts easily, and you can save your time and you can make these concepts understand much more faster. I'm also going to talk about the best books and what are the best online resources available so that the learning is much more faster, easier, and yet the fundamental concepts are getting ingrained in your brain effectively, nicely, and the learning of differential geometry in future with the complexities becomes much easier. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to lesson 19 of differential geometry, learning the fundamental concepts easily, effectively, and saving with time, and what are the best books and resources available. Well, I would like to take a different approach in this video. So till now I have been detailing about books, lot of books, reviews, details about the books, and as usual I'm sending those books to you. But what I would like to do today in this video is to talk a little bit about specific and notes and the lecture notes. Now, why I am doing so? So you see, lecture notes actually are condensed complex ideas and concepts into concise and focused summaries. Books are genuinely books are good, but they are very detailed, and you have to start right from the beginning, completing everything. Also, you will see that lecture notes are typically, structured with an outline reflecting the course or the logic or the flow of the program. Books may lack same level of organization, and it acquire additional effort to identify and connect with related concepts because books starts extensively and you have to go right from the beginning. So it might happen that you might not enjoy reading this book because it is not organized up to the same intelligence level which a lecture notes can be. Now, reading a complete book obviously can be time consuming, particularly for those with limited or you have a very tight schedule, you don't have the time to read. I would prefer to do for specific notes which are usually prepared by the instructor or expert in the field, ensuring that the matter is presented in a tailor-made and specific audience. So you see, I won't say that the books are bad. I have been sending books, and I've been doing a lot of reviews on books, and I will be doing, but this is a different approach where I just want to show you that how effective it is and how it is much more less time consuming. Obviously, books are the best way to learn, but in this kind of a rat race, when you are going through semesters and examinations and a lot of other preoccupations, specific or lecture notes sometimes become very useful. So you don't have to go right from the beginning, you don't have to do extensive reading, more or less these lecture and specific notes are very much up to the standard or up to the intelligence level of the same audience. So I would like to take this approach, and first I would like to tell you that taken this huge ocean of differential geometry, what are the basic fundamental concepts, or how can we divide differential geometry into basic fundamental concepts coming up in this part of the video. So first, definitely what comes is a manifold which deals with shapes or space. Then comes something important which is called tangent spaces, and these are actually vector space that captures the idea of local linear approximation. Don't worry, I will just give you a brief idea of this fundamental concept. Why? Because after that these notes will become effective. Vector fields, a function that assigns to each point a space. So you can imagine vector as a single arrow. Now it can be imagined as a collection of arrows, each one attached to different points in space. Also, what is important is the geodesic. Why? Because the curve represents the shortest path between 2 points, especially in case of a Riemannian manifold. Here comes another very important yet a little bit complex understanding, which is called differential forms. It is a kind of a mathematical object that helps us to describe and measure quantities like area, volume, or flow in different dimensional spaces. Next, what we get is curvature. This is something central which covers, I would say, embraces everything regarding differential geometry. So it measures how a manifold deviates from being flat, and it characterizes bending, twisting, and stretching of the manifold. Lastly, what we get is what is called a Riemannian metric, and this is a metric which actually defines a notion and distance of an angle on a manifold. It assigns a positive definite inner product to each tangent spaces, which enables the measurements. So these are the 7 important concepts. If I can go back, you see 1, 2, 3, 4, 5. So manifold, tangent space, vector fields, geodesics, differential forms, followed by curvature and Riemannian metric. So we would consider that we have broken down differential geometry in 7 fundamental concepts, and now we will go forward in understanding and getting the best resources of that. The question is that which one to study first. Shall I start directly with differential manifold, or shall I go into Riemannian metric, or shall I first study tangent spaces? I'm going to show and going to justify why the sequence has been arranged. So first comes what is called a curvature, which is very central, and it can be thought as the amount by which it bends or curves. So we also call it as a Gaussian curvature of a surface at a point. It's measure how much the surface is in both x and y directions at the point. It also shows that the curvature of a surface can be thought as the amount by which it bends into dimensions. So the very first process of learning differential geometry would be to learn the curvature. And why? The reason is here. Because entire differential geometry revolves around the fundamental concept of bending and twisting and Gaussian curvature. So until and unless you learn curvature, it will be very difficult for you to proceed other. So the sequence of study, sequence number 1 is curvature, and the reason is that it bends, curves, and it actually shows by the amount by which it bends and curves. That is what curvature measures. The second point, when we are dealing with curvatures, we are done with the bends and twists. The question is that where it bends and twists. The answer is this. Point number 2, manifold. So you see, manifold is basically something where it looks like ordinary space, but when you zoom in up, it looks like a bendable and flexible shape. So in manifold in differential geometry is a mathematical object that looks like ordinary shape when you zoom in enough. So here on the right hand side, you can see this is a kind of a manifold I have highlighted in red, and when it is zoomed, it looks like a flat surface. So the manifolds have a certain number of dimensions, but they are curved. The key idea is that even though the entire object is curved, small enough regions on the objects look like flat spaces. So here on the right hand side again, you can see a torus. If I magnify this torus, what I will get is this region, and again when I magnify further, I get what it is called a flat. So here you see, mathematically manifold is defined as a space that is locally homeomorphic to a Euclidean space. That means you can find a small neighborhood around that point that can be smoothly transformed into a flat Euclidean space without any folds or creases. Okay, so we understood what is called a curvature. Now we understood how curvature plays an important role on the surfaces, which are manifolds. So these two concepts are being done. When it is zoomed, it looks like flat. Now the question is that these manifolds, how do we measure them? That is what we measured them using tangent lines or tangent vectors or tangent spaces. So you see tangent space, I am not dealing with tangent vectors because in all of the learning of tangent spaces, automatically tangent vectors will come. So tangent space is a set of tangent space, as you can see in the diagram, with a point P of a manifold together with the operations for addition and multiplication by scalar is a vector space. So at any given point on the sphere, for example, there exists a tangent place that just touches the surface of the sphere only at that point. We can also say that the tangent spaces at a point on a curved surface is a mathematical concept that approximates the local behavior of the surface near that point. It helps us understand the directions, rate of changes, and other properties related to that point of the surface. So it essentially deals with something which is called a local behavior of that surface. And as you know, I have been speaking about difference between differential geometry and topology. So here it is differential geometry certainly deals with something local. So it is a plane representing a local flat space, and it is called why a tangent plane? Because it touches just the surface of the sphere. Now the question is that we understood that how we measure tangent spaces, etc. Now Next comes is that those lines which are going, these are known as vector fields. So fundamental concept number 4, a vector field assigns a vector at each point on a manifold. On the right hand side you can see at each point, all these sphere, there is a line, small brownish line. These are called vector fields. So you can think about a wind. If you can imagine a field where each arrow represents the strength and direction, so the arrows would show how the wind is blowing at different spots. Again, something very local. So vector fields are used to describe the motion of objects, so they are obviously very important in physics and engineering. So these deals with actually the field, and it shows that how wind is blowing at different spots. Now the next important is obviously what is the shortest line that actually signifies a manifold, and that is what is called a geodesic. So here it is, a geodesic is the shortest path between 2 points on a curved surface, and you can imagine you want to go from one point of the sphere to another. The shortest route is not a straight line, but something which is curved. And obviously there is a huge importance in geodesics on a curved surface because it helps navigation of robotics and optimization problems. So we started with basically the curvature, then we moved the curvature to manifold, then from manifold to vector spaces, and then the vector fields, and then tangent spaces to vector fields, and now the geodesics. Now these geodesics actually, even if you want to understand how it moves, bends, twists, etc., they are guided by something which is called a Riemannian metric. So Riemannian metric actually defines the notion of distance and angle on a manifold, which is typically this one, a Riemannian manifold. So Riemannian metric plays a crucial role because why? Because it defines the geometry of the manifold, including notions of curvature, geodesics, and volume elements. So what is happening is that all these things which are moving around, this is actually done in what is called a Riemannian metric. So it defines the notion and it tells how things are bending or curving. So if you manipulate and work with metrics, it can be algebraically complex. And understanding the geometric implications, this actually helps in different metric properties, and it helps us obviously in visualization and etc. So this is fundamental concept number 6, which is called a Riemannian metric. The last which comes, which is a little bit complex, is called what is a differential form. Now see, differential forms actually is something which introduces a concept which is called coordinate independent framework, so that we can express geometric quantities on a manifold. So we can say differential forms are mathematical objects to study and describe the behavior of quantities that change as you move through space. Right, and it helps to understand differential forms. We have to have a very good understanding of calculus, and in calculus we learn about derivatives. Here comes the most important. In differential form, it is a generalization of the concept of derivative, nothing else. It is just a generalization of the concept of derivative because we are dealing with manifolds. So now we have understood these are the 7 concepts, and these are the 7 ways or the 7 sequence. We will first start with curvature, and then we will at the end learn something called differential form. And this is the sequence of this study. Now what we come is that what are the best online resources and books which are available one by one, but understand that this sequence is not the same sequence as the learning sequence. This is just an ordinary sequence where I will show you what are the best resources and books available. So first we will start with the University of Michigan. I have put out the university's website also on the left hand side so that there is no question of authenticity. And this is a nice book which is called Manifolds, and it shows the definition, it shows the examples, it shows a lot of photographs, illustrations, etc. And this is the website from which you can download: department.math.lsa.umich.edu. But don't download, just hold on till the end because I'm going to tell how you can get all those things. Then comes, this is a website which is written by Brian King, and it introduces manifold in a very simple and a clear manner with lot of illustrations and simple English. This is actually the website from where you can download. This is, I would say, a very easy layman's approach. The mathematics is also quite easy. The illustrations are far more reachable and easier. It is coincide. It doesn't contain too much of complexities. It's a wonderful resource to learn about manifold. And thirdly, I would say if you are interested in a little bit more mathematics, you can go for this book, Introduction to Differential Manifold and Riemannian Geometry. This is obviously a complete book. I think it is around 400 pages. It starts with Introduction to Manifolds and then goes into vector fields, tensors, tensor fields. Again, as I told you right at the beginning, that this book would be again an intensive and exhaustive read. But anyway, you can go through this manifold. I would also request the viewers to wait till the absolute end of this video, the last screen, because I have got something new to share with you. Now we come to the best online resources of curvature, and we will start with the Department of Mathematics of University of Hawaii. And here is a nice literature on curvature, and it is written by E.L. Lady, and this is absolutely fantastic. This is the website of Hawaii University, and you can download this book. This is mathematical, but each and every mathematics is being defined and it is being illustrated, it is elucidated in a very nice manner. The next would be the Iowa State University. This is a very good book by Yan Bin Ja. It is a notes. I would say it is a kind of a notes, and you can download this from this faculty states.istate.edu. This is a PDF which is absolutely a gem of a resource and is written by Yan Bin Ja, and it is quite updated September 2020, so you can go through that. Next, what comes about curvature is the famous University of Texas at Austin, and this is again an overview of curvature written by Ashwin Devaraj, May 2020, quite updated. This is not very intensive, easy to understand, and this is the website through which you can download. Then we come to the Rutgers University Library. This is a nice book. Now note that this is by Philip Anthony Beryl. Although this is a kind of a thesis, but I have read this book, this thesis. It is super easy, very simple and interesting, and it gives you a complete idea of curvature. This is the website through which you can download. I have given all these links in the description also. I will come to that part later. But don't be misled that because it is a thesis paper, it would be very complex. No, absolutely not. It is absolutely super easy thesis paper which you can read through. Next we come to tangent spaces, and here is SN Bose National Institute here in Government of India. This is a wonderful literature of tangent space, and you can download this through this. This would be a little bit mathematical, obviously, because tangent space deals with mathematics, but the proofs, the propositions, the theorems, it is quite easy. If you just know the basics, I think this would be the best and one of the best literature to know about tangent space. Next we come to the Caltech, the famous Caltech University, and in the Department of Mathematics we got a nice book and literature on tangent spaces, normals and extrema. This is the complete URL through which you can download. Caltech although has got enough amount of resources on tangent spaces, etc., but this specific is simple, it is quite easy, and it does not delve too much into the complexities, so my recommendation would be this one. The next comes the University of Arizona, the College of Science. This is again a tangent space book by David Glickenstein, and you can download this book from here. This is also quite good. Okay, so now we come to the vector fields, and vector fields, I would say not much resources are actually available. There are a lot of resources available, but this website, Calc Workshop, this is really nice, and I would say it starts right from the beginning by dealing with vector fields, how it is defined, the three space. It is super easy, well written, coincised, not much of complexities, and it doesn't explain too much of other details which sometimes confuses a reader. So it is a wonderful book to read. This is a nice website. You can very well go and read the vector field plus other stuffs which are there in Calc Workshop. We come to the complexities now of geodesics, and this would be Pennsylvania University of Mathematics. This is again a book by Hermann Gluck. Again, I would say it is super easy. It is absolutely clear, coincised, lucid, not much of complexities are there, and you can download this from this website. I can tell you, if you start learning geodesics, not even going to the geodesic equation, but still read this literature, this would be super easy and quite good. The next comes Institute of Mathematics of Heidelberg, and this is a book on geodesics and obviously related to different Riemannian geometry. This is also a very easy, quite understandable book, and it doesn't contain much of other mathematics. It just starts with the motivation, definition, and you can download this from this website. Next comes this one, Iowa State University. This is again Jan Binja Geodesics, and you can download this from this website. This is too good. So now we come to the best online resources for Riemannian metric, and I can send you Bhaskar Acharya College of Applied Sciences. This is the New Delhi. This contains a wonderful literature, and I can tell you honestly, I have used this literature and this book extensively in many of my videos of metric tensor and Riemannian metrics. The derivations are simple, the equations are easy, the explanations are absolutely lucid and clear, anybody can understand. This is the website I have given, although it says metric tensor, but it contains basically obviously Riemannian metric and other things. You can go ahead and download it. The next online would be this one, again University of Pennsylvania. It contains a beautiful article on Riemannian geometry. Now this is chapter number 11, but the entire book and the resource is here. It is one.pdf, and it is actually written by John Gallier of that university, and it actually deals with manifolds, Riemannian metrics, Lie groups, Lie algebra, and homogeneous manifolds. If you want to read that book itself, it is I think around 250-300 pages book. You can go ahead with the last PDF download, the last link. But if you just want to do the Riemannian metric, the first one will be great. This is by Institute de Matemática, that is Sao Paulo, and this is also a wonderful book. You can download it. It is quite simple. Again, this is chapter 1, so it will contain further details, but it is unique, and I can tell you it is very simple, and the author has done a fabulous job. We come to the last one, which is the best online resources for differential form. It is quite a bit complicated. I will make a different video on differential form, but this one, Purdue University Department of Mathematics, this is a wonderful book. Remember, this is a book which contains introduction to differential forms. I have not given the book because otherwise it would take another few minutes to explain it, but you can trust me, this is a wonderful book. It contains differential form in the easiest format, and this is the link through which you can download. The next thing which comes is Northern Arizona University. This is again a complete book written by Schulz and Schulz, and it contains differential forms in a very easy level. This is the book which is available. You can, if you wish, you can download. And here it comes from the famous Massachusetts Institute of Technology, MIT Mathematics, and this is the book. Again, it is a complete book which will contain everything regarding the differential forms. Okay, now how to get these resources? You can always WhatsApp me, and you can always write to me regarding these resources, because now you see the resources are not only books, it's a mixture of books and lecture notes. The first thing is that I have given all those lecture notes and books in the description box of this video. You can go ahead and download each of them. But if you feel no, downloading will take some time, bandwidth, and you don't have the time, what you can do is that you can email me, and I will send all those things in the in our email. So my email will contain all the links regarding the notes, lecture notes, semi notes, books, etc. You can very well go ahead and download them. So I would be immensely thankful for you for watching this video, because I have taken a different kind of approach in this video. Please don't forget to subscribe to my channel Physics for Students. Click on the bell icon to get all the notification from Physics for Students. You can write to me at this email ID also, and you can subscribe to my other channel, General Relativity Explained, which deals with Einstein's general relativity exclusively. You can follow me now on my Facebook, Instagram, LinkedIn, and on my Twitter channel, which of late I have started very recently. And also I have a fan page of the famous British cosmologist Stephen Hawking, which is round about 32,000 followers, and you can go ahead and follow where I post lot of interesting stuffs not related to my video or physics for students, but a lot of discoveries, lot of new inventions, lot of biographies, and lot of other stuffs which are related to physics and mathematics, but on a very informal, easy and quick reading manner. So you can go ahead and follow me on this Facebook page of the famous Stephen Hawking, and you will be enriched with a lot of new stuffs each and every day. So that's all for today's video. Please do let me know about the comment on the comment section, and how did you like, and please download these books, go ahead and read, and if you want to write to me, please do write to me. I will be glad to help you. And this is all for today's video. Physics for Students will be back very soon with few more interesting videos. Till then, goodbye, and may the good Lord be with you.